So good morning, good afternoon, good evening, whenever you're watching the videos. We're at now 5.6b, polynomials multiplication, and we're talking specifically in this section about difference of squares. So we're going to make this pretty quick, I think. Difference of squares is just a special situation with multiplying polynomials. So right here, we're going to talk about difference of squares right here. We're going to talk about that one. Let's fast forward through this stuff. Again, here's the summary from page 357 of information you might need for properties of integer exponents. So let's go here and we're going to talk about multiplying the sum and difference of the same two terms. So in other words, if I've got, let's see, if I've got the same term here, 2x and 2x, in other words, I'm multiplying specifically two binomials. It has to be a binomial times a binomial, and the first term is the same in both binomials, and the second term is the same as in terms of value. 3 and 3 is the same, and the only difference is that the first binomial has a plus sign, the second polynomial has a minus sign. Then let's see what happens when we do our FOIL. If we do the FOIL, and again, FOIL talks about first, outside, inside, last. The first terms we multiply together, 2x times 2x. If we take a look at the signs, they're going to be positive times a positive gives us positive. 2 times 2 gives us 4. X times x gives us x squared. So this is our first term. Sorry, that should be in blue. First term is right there. Outside term would be 2x times negative 3, which would give us negative 6x. Inside term, 3 plus 3 times plus 2x gives us plus 6x. And the last term is plus 3 times minus 3 gives us minus 9. And now the step that we have to do is take these two and combine them. And that's the important thing here, is that when we combine the like terms, minus 6x plus 6x, they're like terms because they have the same exact variable to the power, same exact power. Minus 6x plus 6x goes away, and that becomes 0, and what's left is 4x squared minus 9. And this multiplication, this product, is called the difference of squares, because we've got a difference of two squared terms. In other words, the first term is 2x times 2x is really 2x squared. 2x squared gives us 4x squared, and that's our first term that we get here in our difference of squares multiplication. The second term in our multiplication is plus 3 times minus 3, and that gives us minus 9. And the important thing is that 9 is a perfect square. That 9 is a perfect square. So we've got the difference right there, the difference, subtraction is difference, of squares. 4x squared is a perfect square, 9 is a perfect square, and there's the difference of squares. So if you see something like this, where the first terms, it's got to be a binomial times a binomial. First one in each of these is exactly the same. 2x is the same as 2x, 3 is the same as 3, and the only difference is you got a plus here and a minus here. Then you get the difference of squares. You can just shortcut to 2x squared gives me 4x squared, and it's got to be the entire 2x squared. The entire 2x squared. 2 squared is 4, x squared is x squared, and that has to be here. And then 3 times 3 is 9, gives us 9, and then the subtraction goes between them. Alright, so special terminology for this is that these two binomials are called conjugates. 2x plus 3 and 2x minus 3. They're just called conjugates, and that's just a kind of a special term for both of these. First term is the same, last term is the same. Subtraction here, addition here. Those are just called conjugates, something to remember. Now, is it important that here's a plus sign here and a minus sign here? Would it be the same thing if we had a minus sign here and a plus sign here? Well, it would be the same. We'd get the same thing because the outside terms and inside terms would still cancel out, as minus 6x plus 6x would cancel out to 0, and we'd still have left the first term squared and the second term squared, and we'd have the same kind of result. All right, let's go to the next page and we'll do some examples here. Alright, remember, I guess our rule here is if we've got a minus b times a plus b, these are called conjugates. A minus b is the conjugate of a plus b. That will give us a squared minus b squared, and that's called the difference of squares. And you'll have to remember that. We'll kind of go backwards from the difference of squares here to our factoring in the next chapter. So it'll be important kind of to remember that rule here. But right now, if we've got the a term as the same, the b term is the same, and there's subtraction in one and addition in another, then we get the product here, a squared minus b squared. So let's go through a couple examples. I'm going to go through one. We kind of did one already, but we'll go through another one. So the first question I have is 5x minus 2 times 5x plus 2. Alright, so there's my question. We can go through the FOIL method. We can say, alright, well, first outside, inside, last gives me, first would be 5x times 5x is 25x squared. Outside would be 5x times 2, or plus 5x times plus 2 gives me plus 10x. Inside is minus 2 times 5x, positive 5x, would be a negative 10x. 2 times 5 is 10. Negative sign for n times positive is a negative, and x times nothing is x, or x times x to the 0th power more specifically. And then minus 2, to finish up the FOIL would be minus 2 times plus 2 gives us minus 4. Plus 10, and now we combine like terms. Plus 10x minus 10x goes away because that's equal to 0. And we have what's left, 25x squared minus 4. 25x squared is that 5x, my a term, squared. 5x squared is 25x squared. Again, the b times the b is going to give me b squared, so 2 times 2 gives me 2 squared, or 4, and then a subtraction between them that gives us the difference of squares, and there's our answer. Alright, I'm going to put up two different questions here, and you're going to go through those yourself. Pause the video and go through these and say, here's 3y minus 4 times 3y plus 4. And if you don't need to pause the video, you might not need to, but it might be a good idea just to kind of get some hands-on practice yourself. Here's y minus 7y plus 7. And then, so pause the video, go through these, see if you can take the shortcut maybe, and then just get an answer. See what answer you get. And it is the same as mine. Alright, here's my solution. I'm going to fast forward through this. 3y, because I've got now a minus b times a plus b, a minus b times a plus b. Here's my a term is 3y, b term is 4. Subtraction here, subtraction here, addition here means that I can take the shortcut and give me an a squared term. So it would be 3y squared minus 4 squared. And now I can just do the multiplication and say this would be 9y squared minus 16 as an answer. Alright, next one here, again, we're going to take the a minus b, a plus b, y is the same as y, 7 is the same as 7, subtraction and addition. Then I can fast forward and I can say this is going to be y squared, subtraction between them, 7 squared is my last term, and this just gives me y squared minus 7 squared, I'll make it 49, sorry. And there's our answer. How did you do? Alright, question for you now. Here's our homework question. Hand it in with your notes. 4a minus 5, and that's an a, sorry, times 4a plus 5. Give me the answer down here and tell me what a is, what b is. We have to separate them by subtraction. Give me the answer in your homework notes. Alright, see you soon in the class.